On the previous video, we have looked how to design this end bit add sub module in structural way. So we simulate it and see the functionality of it. Now we're gonna design the same function add subtraction, but on behavioral way, no structure. So we're gonna design a behavioral end bit sub. So we need to create a new Verilog file and save it as end bit behavioral add sub. Save it. So the first thing we're gonna do, we're gonna declare the module name. So module, the name must be the same as the file name. So end bit behavioral add sub, and we need to declare our inputs and outputs in here. So we're gonna have control x, y, and sum, and a carry out. So they are same as the previous design. So but now we will not add the overflow bit, since the functionality are equal to the previous one, the structure. So we need to end this module, end module. So the first thing we're going to declare our, since the end bits add sub should be parameterized, so that means that we can change the range of the summation or subtraction. So we need to declare parameter. In our case now it's going to be 4. The default value of it is going to be 4. And then our inputs. So the first input is the control. So the is single bit. And then we have input of vector, 2 vector. So we have our input of 2 vectors, x and y, which have the length of 4 bits. So it's parameterized, by the way. So the vectors are x and y. And then we need to declare our output. But since this design is going to be behavioral, so we're going to use the output as reg, because we're going to use an event driven block. So output must be declared in reg. So reg, the first output of this is the output s, is also a vector with the length of 4. So it's s. And then we have another output, reg, but this is a single bit. This is carry out. The difference between how I declare this one as reg and the previous one we declare without the reg, because we use a sign. When we use, if you can see here, we use a sign. So when you use something called a sign, you don't need to declare reg. But here, since we're gonna use event driven block always, so always, this is an event driven block. So begin and then end. So whatever is inside here, the code that we write, it will run only if there is a change in a value of the thing that we're going to put inside here. So the first parameter we're going to put here, we're going to check is x, y, and the control. If one of them change, we're going to run the code. So this is how a event-driven block always works. So it's x, we're going to check y, and the control. So if either of them change in value, the code will run. So what code we're going to run, of course, is plus and minus. So the sum here is just equal to, for example, x plus y or x minus y. This is arithmetic summation or subtraction. But we need to control with a controller, so we're going to use a multiplexer inside here. So we're going to check if the control, if we want to do summation, the control must be 0. If we want to do subtraction, the control is 1. So if control is 1, so that means that we are doing subtraction. If control is 1, so it's going to be true. What we're going to do, sum is going to be equal to x minus y. So this is the first implementation. And then the second one is we're going to check else. So if else control is 0, what we're going to do is the sum is equal to x plus y. So this is the behavioral. We are just using normal arithmetic summation and subtraction. So we are leaving all the design, the compiler. So the Intel compiler will take care of how the block are added inside there. So it's like a black box. We don't know what has happened behind that. Now what we are missing is a carry out. So carry out here, we're going to put it inside here. So on the carry out, we're going to use something called concatenate. So it means that if for example the summation, if it is larger than 15, we're going to have a carry out. So we're going to use concatenate, so that value, it will be add on the next value. So that is carry out. So we're going to have here the concatenate here of carry out and the sum. If the answer is below 15, is going to be added here, but the last carry is going to be added here. So this one is the same for this one too. So now we have solved the issue for the carry out. So let's just save it and try to analyze and synthesize. So you can see we have some error here. Let me check it out. Yeah, of course, we are missing at here. Save it again, analyze and synthesize. So on the next video, we're gonna design a test bench for this one and test it.